Alright, so quickly, what we're going to study right now is the quadratic formula. And we are recording, just so you know. Okay, the quadratic formula. Now, what I'm going to do is start with an example where we can solve a quadratic by factoring. Okay, by factoring. And you've seen this before. And then we're going to prove that this is true by using the quadratic formula. Okay? And you're going to have to accept my word on this today, and you'll see that it works. But there is a derivation of this, or a proof of where it comes from, that you might go over this year in Algebra 2. Steph.
Can I move my seat up?
Where to?
Over there.
No, not on this side.
Over here?
Can you really not see, Steph?
Yeah, because when I take notes, it kind of like I can't see, and I don't take notes. It frustrates me, and I just don't want to give up.
I agree with you. Can you sit next to Hunter over here?
That's the same thing.
Yeah, that's the same one.
There's no room over here, though, Steph.
Okay, I'll just quit and get wrinkled, Johnny. That's fine.
Maybe a classmate wants to switch with you that's in the front, but I'm not going to just start putting it in here. All right, quadratic formula. Let's look at the example. X squared plus 5x plus 6 equals 0. Okay? X squared plus 5x plus 6. What would you do, Tristan? Good. What would the factors be for this one, Tristan?
X plus 1, well, plus 5.
Don't do the 5 and the 1. This is very confusing because the 5 and 1 were 3 and 2 here. Remember? You're going to use 3 and 2 here.
Yeah. Oh, that's hard.
Right? This is the one that confuses a lot of students. They use 5 and 1 instead of 3 and 2. 3 plus 2 gives me the 5 in the middle. 3 times 2 gives me the 6 at the end. If you FOIL this back out, you'll get the original line. Okay? Good. So our solutions for this are two of them. We have x plus 2 equals 0 and x plus 3 equals 0. So we say x equals negative 3, x equals negative 2. And you've all seen this before in factoring. I know that. Now, what I'm going to do next is show you a formula that avoids factoring altogether. And we're going to use it in physics, because in physics, when we have x squared or t squared like last night's work, we don't have numbers that are very simple, like 5 and 6. If you notice, we have numbers like 9.81, okay, or decimals like 10.7. So they're not really factorable. So for that matter, or for that example, we have to use the quadratic formula. So I'm going to show you now on the right side how to use this. So if we start, identify this coefficient here as A, this one as B, and this one as C. Okay, so call this A, call this B, and call this C. Now, what is A, even though it's not there? Good. There's a coefficient of 1 in front of you. Remember, there's really a 1 there. So whenever you don't see a coefficient, remember there's a 1 placeholder there. Please don't forget that. Okay? If the C is not there, what is C though? Steph?
0.
0. Again, if there's nothing here, it's a 1 for B or for A. But if C is missing, C is really 0. Now, the quadratic formula tells us the following. X equals, anybody know it? Anybody hear of it before? Okay. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A.
Okay. Doesn't exactly ring a bell.
Right?
That one might have slipped my mind. I might have been absent that day.
Well, you know what it is? In some schools in Algebra 1, you're taught the quadratic formula. Some schools wait till Algebra 2. So I talked to Ms. Sarusi, and she said, "Oh, we don't go to the quadratic formula until Algebra 2." So, you know, in the past, I had taught some students that had learned in Algebra 1. So I wanted to make sure that we all get it, so we can all see what it is. Now, it looks very complicated. It is not complicated. Okay? It looks very complex. But A, B, and C are just numerical values. They're just numbers. And those numbers are right here in the equation. Whenever the equation is equal to 0, the quantities A, B, and C are simply A is whatever's in front of x squared always, B is whatever's in front of the x term, and C is whatever is the constant or the thing by itself. Now all you need to do is just plug in those numbers up here. Literally, just plug them in. So go through the steps. All I want you to do is this. Plug in for B. So B would be negative B plus or minus the square root of B squared minus 4AC all over 2A. So I'm literally just plugging in the numerical constants, A, B, and C. So far, so good?
Yeah.
Okay? This is algebra 1 in this sense because all you're doing is evaluating an expression. This is an expression, we are evaluating it. Please go ahead and see what you get under the radical. Try and simplify this. So simplify under the radical first, please. That's not annoying, I don't know what it is. Is that outside?
Is that Sibylla's phone again?
See that?
Alright, that's really funny now.
What do you get under the radical? You better get a number from me under the radical.
1/2.
No,
One.
you get one under the radicals.
I agree. I
Oh,
agree with you.
yeah, I was dividing.
Let's take a look.
Oh my god.
5 squared is
25.
4 times 1 times 6.
24.
So we have, relax, 25 minus 24. So under the radical, turns out to be just a 1. It's not always going to be that pretty. So if you're on like a 2 under the radical, you can't really take the square root of 2. You're going to have to approximate it with a decimal. But for this example, the square root of 1 is just, what's the square root of 1? 1, right? 1. Should you all say that, please? All right, let's continue. If I continue to solve this.
I have a question.
Uh-huh.
Do you can leave it just like that?
No, we'll keep going, we're not done.
Oh.
Continuing.
Does he look like he's done? I don't know.
Let's focus. We have -5 plus or minus 1 over 2. Because again, the square root of 1 is just 1. Had this been a number like 49 under the square root, what would this be right here? 7. Had this been 64? Okay, so whatever it is, you square root it.
I know what to do.
Thank you, Tom. Tell me what to do.
Don't you? Oh, wait, never mind. I was going to say, if you left the 1 in there, and this for other problems, you have to do the 2 and then times it by radical 2 and then all that stuff.
That's rationalizing the denominator you're thinking of. Here, see a plus or minus there? Break it into 2 different solutions. Do one with a plus, and do one with a minus. Okay, again, see what I did? I took the plus or minus, and I broke this solution up into 2 different solutions. First of all, let me go back real quick and say, why do I know I'm going to have 2 solutions here? Why do I know, Aggie? Okay, the plus or minus, very good. That definitely indicates it. But before the formula, Emmett, why do I know there's 2?
Is it really your factory?
Because when I factor a quadratic, how many answers do I get, guys? 2. The reason being is because it's x squared. If it was x cubed, how many answers would you get? X fourth. Okay, so the degree, which is the exponent of the polynomial, is the amount of answers you're going to get. So if it's x to the 5th power, and you actually found the roots of that, you would get 5 answers. X to the 10th power, 10 answers, and so forth and so on. Okay, they might be imaginary, but we're not going to get into that right now. Let's do this. -5 plus 1. What's -4 divided by 2? Over here, -5 minus 1. Over 2.
-3.
And take a look. My 2 answers, aren't they the same? So we got here. These 2 match up right here. And these 2 match up right here.
Yeah, look at that.
So whenever you have a quadratic,
Just said the same thing. That was so weird.
whenever you have a quadratic, if you can factor, you should definitely factor because it's a lot easier than doing all this work. But in physics, there's a very small chance you're going to be able to factor because problems are going to have examples like this. Our examples in physics are going to look like this. Maybe like, let's go with this. Well, let's just make another one. -9.81 t squared plus 2t minus 7 equals 0. If you had something like that, and you need to find the time it took for the projectile to land, and you're solving for t, it's very tough. It's almost impossible, actually, to factor this, okay? Without certain techniques that are way beyond even high school level math. So instead of factoring this, you're just going to use the quadratic formula, where this would be a, this would be b, and this would be c. Now remember, c in this case would be -7. A would be -9.81. B would be +2. Okay, so whenever you have a quadratic, put it in order from squared, so squared first, linear second, and then a constant third. Always in the correct order, and then you label them A, B, C. Okay, let's look at an example of this. Let's look at one example of this. If we have, let's see. An object is launched with an initial velocity of 12 meters per second, and it travels vertically 25 meters. Find the time it takes. Okay? And I did not give you any problems like this yet because we didn't go over the quadratic formula. But what you'll notice is that in your homework for section 2-3, find the time it takes to get to 25. Sorry, to get to 25. In your homework, you're going to notice for section 2-3 that a problem like this might occur where you need to actually use the quadratic. Okay? So, give me some givens here. What's my givens? Green. Good. What else have I got? Green. Keep going.
You have your displacement, 25 meters. You have your acceleration, -9.81 meters per second.
And what are we looking for, Green? Okay. The only formula that will work for this, the only formula that's going to work is x equals VIT plus 1/2 AT squared. Okay, the other ones don't work. We don't have a VF, so we can't use any of the other two formulas automatically. We do not have a final velocity here, so we can't use VF equals VI plus AT, and we can't use VF squared equals VI squared plus 2AX. Neither will work.
You can't find VF doing another equation.
You could. There's a possibility you can try and find VF here and then plug it in. But if you don't want to use two equations anymore, it's not easier to use the x equals.
How did you know it was -9?
Given. Why? Where are we, guys? What planet?
Earth.
That's the Earth's gravitational constant.
Oh my god.
That's what you need to memorize. So,
X is 25.
You know what?
very good. So x is 25. Let's plug that in, please. VI, which is the meters. What was VI in this problem?
12 meters per second.
Wait, I don't understand. You don't have time.
That's the thing here. That's why it's quadratic. Look. Take a look, guys. We're going to solve for time. It's unknown here, and it's unknown here. So we can't solve this by standard methods of rearranging. We have to use the quadratic formula. That's what I'm going to go through.
Wait, can you move up a little? I don't really understand. Wait, you rewrote the formula? Oh, that's better. Thank you.
Okay? The
Yeah.
formula's given, and then we just plugged in. Now, this is the only time that I'm going to tell you to drop the units, because it's going to get a little bit messy if you don't. We know time is going to be in seconds, because every other unit is standard. We have 25 meters, we have a 12, what's a 12 there by the way? 12 meters per second, and we have meters per second squared. So for now, drop the units. Write this as 25 equals 12t. Anybody, what's half of negative 9.81?
-4.9.
45.
Oh, fine, close. Okay? So again, all I'm doing is dropping the units, and I also happen to be simplifying whatever this number is right here. Okay, again, 1/2 times negative 9.81 is the negative 4.905. I just simplified those two values by multiplying. Now, at this point in time, it's a quadratic, just solve. But what do we have to have on one side of the equation? What is it? Zero. Remember, if you factor, you need a 0 on one side. Same thing here. So what should I do with this 25? How can I get rid of it? Subtract it, please. And I'm going to say, right now it's going to look messy, and I'm going to rearrange it, but just so you can see that I can rearrange it here. this is what I have right now. Again, I'm subtracting 25 from both sides. And I can't subtract 25 from either of these two terms because they have t's in them. So I just tack it on the end. But take a look. Is it in the correct order, the equation? What should be first? The square term should be first. So at this point in time, we have 0 equals negative 4.905 t squared plus 12t minus 25. Okay? And now it's a quadratic. Now it's a quadratic, Tom.
I, for some reason, felt like I wanted to have negative 4.905.
That's fine. So if you, Tom makes a good point here, people. Listen, he said, I want to make the 4.905 positive because it just feels better, right, sometimes? So, if this were positive, you would have taken this quantity and added it, taken this quantity and subtracted it. So it's the same thing as switching all these signs. You can always switch all the signs, by the way. Watch. If I multiply this side by negative 1, and I multiply this whole thing by negative 1, what's going to happen is this is still going to be 0, because 0 times anything is 0. And all of these signs are going to switch. So this would become a positive, that'd be a negative, that would be a positive. But it doesn't matter with the quadratic formula if it's a positive or negative leading coefficient for A. It makes no difference really. Okay? I didn't. I'm saying because Tom asked the question, if I wanted the first coefficient to be positive, he moved it over here, which would have made it positive, but you don't need to. So you can leave it the way it is. Oops.
Yeah, it's making it more confusing.
All right. So at this point in time, identify your variables, please. Somebody tell me, what is A? Helen.
Negative 4.905.
Good. Somebody else for B. Nicole. 12. And somebody else even for C now.
Oh, negative 25.
Negative. Very good. Good job remembering the negative signs. Now, go to your formula, which, by the way, I will provide you with. I'll give you the quadratic formula. You don't have to memorize it. Okay? And there's also ways you can write a program in your calculator. Anybody know anything about computer coding? Anyone study computers at all?
Yeah, me.
You can write a program, and I can teach you guys how to do it. You can write a program on your calculator that you just run the program, and it says enter A, and you would just type in negative 4.905. Then it'll say enter B, type in 12. Then it'll say enter C, type in negative 25. Hit enter, and it'll calculate the whole formula for you. It'll give you the two answers.
Wait,
Very
that's like
easy
magic. What was the thing?
I'll tell you after one. All right. All right. So A, B, and C we've got. You guys want to hear a stupid jingle that works with this pretty well?
Yeah.
I have to memorize it.
Jingle.
I'll probably learn like a jingle when we get to this out of two.
Sing to
All right. Who knows Papa's Louisa? Who knows Papa's Louisa?
I know it.
Anyone know Papa's Louisa?
Yeah.
All around. What is it?
I don't know.
All around. No, very much. Monkey chase Louise. You know the real words?
All I know is pop.
Anyway, all right. So the two of the pop goes to weasel. Ready? So say it like this. And I don't sing well, but I'll just hum. So it's gonna be.
Belt it out.
It's gonna be
Come on,
x
play
equals.
karaoke.
Come on, listen. It's gonna be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Why?
Pop goes to weasel. You can be any song you like, of course, but when I was younger, I learned this in 2nd grade math, which is interesting. And Miss Carpenter,
No,
my
you're really
teacher,
ahead of the game.
Miss, there's a different thing. My teacher, Miss Carpenter, taught us this song, and actually she gave us a quiz. And the quiz was to come after school one day, and you had to sing the song or sing the quadratic formula to the tune of it. And that was like the quiz. You either got 100 or you got 0. It was interesting, but it actually made me memorize it. Okay?
What if you were out of tune?
I mean, it didn't matter the frequency, but you had to know the words. All right, let's plug in, please. Let's plug in.
He dabbles in song.
Now, B is positive, but remember, if B were negative, you're still squaring it under here. So remember, if b happened to be negative and you squared it, this b would become positive, really. So keep that in mind when you're doing this.
Oh my god.
That's why I put the parentheses there.
Stop yelling it out.
You look better with the lights on.
Enough with that comment, please. That's not nice.
Kind of funny.
Do I look like I find this amusing?
I know. I'm just saying. The comments.
No.
So, plug in here.
No, you got it.
What do we get for this? Now, take a look, people, right away. Here's what I noticed first. Everybody see negative, negative here? See negative, negative? What does that tell me?
Positive.
You're going to get a positive for this part, but you have a third negative. You have a third negative here.
Negative.
So it's going to remain negative. Now, what you're going to notice is, unfortunately, I picked bad numbers for this problem, so you're going to get a negative number under here. Okay? You'll see.
Oh my god.
144, this is going to be negative 25 times 4 is going to be negative 100. So it's going to be
No, wouldn't it
negative
be positive 100 then?
490.5.
Wait, wouldn't the negative 25 come to positive?
But we have 3 negatives, people. 3 negatives remains negative. Remember, negative times a negative is a positive, but look, we have negative, negative, negative. 3 negatives become
Negatory.
still negative. So unfortunately, this problem doesn't work because the numbers don't work out. Because look, you can see this? 144 minus 490, what is that going to become? What kind of a number?
Negative.
Negative. And you can't take the square root of a negative. So unfortunately, I just picked random numbers, so this didn't work. But in this case, make believe, hypothetically speaking, hypothetically, okay? So you're not going to obviously, change it. But had this been positive, okay? Had this been positive, what would we do from this point on? Somebody step me through the rest of the problem. Kareem. Yeah, you would simplify this and get a number, right? Then you would take the square root of that number. You got to listen, please, listen. Hypothetically, had this been positive for the sake of this problem, okay? So this would be approximately 634.5. Again, hypothetically. Okay, again, hypothetically. I'm going to keep saying it over and over.
Keep saying it.
Now, you would take the square root of this. The square root of this is probably 30, 20 and change. 23 or 24 maybe. So we take this, what is it? 25? No, because 625. No, that's fine. So this is going to be around 25. So this problem will turn out to look like the following. Approximately 25.8, you said, Chelsea? Okay, and then the last step for this problem is just to break this up into two answers. We make one of them look like this, and you make the other one look like this. Okay? Again, whenever you get to this final step, right here, if you want to circle this, please, at this stage, when you get to this portion, once you've simplified your radical completely, that's when you break it up with a plus here, and this answer with a minus here, and you get two separate answers, and those are your roots. Now, with a lot of these problems, for time, you're going to get two answers. One is going to be negative, one is going to be positive. But for time, we know you can only have what kind of an answer? Positive.
Positive.
So when you get two roots for these kinds of answers, you're probably going to have to reject one of the solutions. Reject one of the solutions. Is that clear? Okay?
Negative.
All right, we've got about 10 minutes. What I want to do now is go over the beginning of trigonometry.
We only have 10 minutes.
Yeah, it's
Time flies.
Oh my god, this test is sneaking up on me.
I'm just itching to take this.
Itching to stay in here.
all right. So remember how I just sang a really corny song? There's a really corny story that goes along with trigonometry. Okay, there's several of these that have been written a long time. But we're just going to read through it. And it's happening, trust me, it's really lame. But you'll remember, it'll help you remember the acronym after you do. Okay? So just bear with me. I know it's a little weird.
Is this so good?
It is Sobertone. You've heard Sobertone story?
I've heard so much.
Have you heard the story?
I've heard some of it. I heard it in
It's a really, there's like how to play that whole movie, right?
My siblings think I would win a couple things.
Alright.
Three prevented the Hunger Games.
Now read the first paragraph for us. Just the first paragraph, please. Nice and loud and clear.
I can read loud and clear.
Is that for me? My birthday
I'm going to go paragraph by paragraph.
Oh, it's a Catholic form. Once upon a time, a long time ago, there lived a poor girl named Erica.
Let's start over.
Once upon a time, a long time ago, there lived a poor girl on a farm. We cannot change the character.
Just go. Come on.
Her name was Erica. She lived all alone. She lived a humble life that didn't involve too much change. She started each day tending her onion and carrot garden, and ended each day with her favorite passion. She loved dancing. Every night. If you guys don't know what proper dance attire is, please call Hannah Storm. Every night as the sun began to set, she would retire into her cottage, turn on her CD, and dance the night away.
Okay, Tom, man.
Meanwhile, the castle prince Fred was wondering what the rest of the world was like. He hopped on his handsome steed and set out to find what the others in the kingdom did with their days. He made his rounds and bumped into a million different people, but nothing made much of an impression with him until he heard a sound. He rode over to Erica's cottage and listened to an unfamiliar rhythm he heard. He knocked on the door and asked her what she was doing. She explained that she was dancing to music. He asked her if she would be willing to teach him how to dance, and she accepted the music.
Francis was a very slow learner when it came to dancing. It appeared that no matter how hard Erica tried to get him in the right steps, he would somehow lose a beat and wind up stepping on her toe. He left at midnight, but asked if she would mind being back for another lesson.
Ow, ow!
The dancing lessons went on, and they fell in love. Fred, aka Tierney, proposed marriage to Erica, and she of course accepted. King Tierney and Queen Erica continued their dancing hobby every Friday night. The only problem for Queen Erica was that no matter how hard she tried to teach King Tierney, he remained terribly clumsy. And whenever they went dancing, he would always step on Queen Erica's big toe.
And we all know Queen Erica loves speed.
Come on.
Queen Erica learned to live with this slight flaw in their true love relationship, but this big toe stomping was no laughing matter. So each Saturday morning, after one of their dancing dates, Erica would wake up early and sneak out and cast on her favorite pot. There she would sit for an hour, soaking her big toe in the toe of the window.
As the years passed by, the whole kingdom would watch the king and the queen rituals, dancing and soaking with delight. Even after the king and the queen died, their love story lived on in the hearts of the kingdom. Of course, like all good legends, time changed the facts as well as the names.
Is this a real story? No. Yeah, the story of Erica's unique.
So King Fred was remembered as King Klutz, and Queen Wilma was remembered as Queen Sokotoa. Because she kept soaking her toe.
LOL.
That's the whole story.
What
Now,
does this have to do with anything on the factory?
I'll explain. Today what we're going to do is this. We're going
This
to
is a
learn
good story for a Friday.
this acronym called Sokotoa.
I know it.
And we're going to split it up like follows. Okay? And you see it at the bottom, I hope, right? So read it for us there.
Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent.
So what we're looking at today is an example where we have a right triangle. So go ahead and draw a right triangle on your paper, please. Go ahead and draw a right triangle, please. Okay? Anywhere, sorry. It doesn't matter. Anyway. Alright. Now, and you can draw, let's draw the right triangle in both directions, please, because we're going to look at any triangle in either direction. So, what I want to notice is this. What we're going to look at is and imagine, if you will, for a second. If I were to just open this door and close this door and just push normally like this, I'm pushing horizontally. But if, let's say, like the handle was jammed and I wanted to like unjam it or I wanted to drop it down, I would have to like push at an angle, right? At some sort of an angle. Or if I were to like throw a football to Kareem and say he was like, 100 yards away, I can't throw, 50 yards away, and I wanted to throw it to him, pretty tough to throw a perfect line dry at 50 yards. What do? You put a little loft under it, right? So it looks like a projectile almost. So what we're going to do this year is we're going to study things that are either launched at angles, or we're going to look at things that are hung on the wall by angles. So imagine if like you saw like a sign hanging somewhere, and there was a cord hanging this way and a cord hanging this way that's holding the sign up. There's angles in here. These are some angles, say 30 degrees on each side. So what we're going to notice all year is that in real life, a lot of things are not just perpendicular or linear. They go at angles, okay? So with that said, we need to start looking at SOHCAHTOA, because SOHCAHTOA is going to break down our angles for us. Okay, it's going to be able to say to us, well, if we have an angle here, God bless you, I have to know what the other parts of it are. So all we're going to do in the next 3 minutes is just label a diagram. So, if we call this some angle 30 degrees right here, okay, call that some angle 30 degrees. Now, if I'm looking at this angle, and I look at the whole triangle now, who remembers from geometry, where is the hypotenuse? Sabone.
It's the slanted part.
Good, the slanted part, the biggest side, opposite the right angle. Very good. So label this hypotenuse, please.
Oh, I do too.
Label this hypotenuse. Now, everybody see this angle right here? Which side out of this side here or this side here is closer to the angle? The first side or the second side?
First side.
The first side, right? The first side in the bottom here. Now, think about the word, before we get into that, think about the word adjacent. Think about the word adjacent. If this room is adjacent to that room, what does it mean they are?
Next to perpendicular lines.
They share a wall.
They share the wall, or they're next to each other, right? They share the wall. So, this angle here, it kind of shares this side and this side to make the angle. But we already called this the hypotenuse. So the other side that it shares, we're going to call the adjacent side. Okay, the adjacent. Now, the last step is to say, well, what's the other side going to be called? Not leg. We had 3 words here. We had hypotenuse, we had adjacent, and opposite. Okay, and opposite. And opposite. Over here now. Let's label this one, and we're going to call this X. Some angle. I don't care what the angle is. But we're identifying this angle, here, X. Somebody tell me where would the hypotenuse be in this triangle over here? Steph.
The slanted one.
Good, the slanted one still. Why hasn't it changed, Steph?
Because hypotenuse is the hypotenuse, and that's the hypotenuse.
Because the hypotenuse is the hypotenuse. Okay. Because it's still opposite the right angle. Very good. Now, this is X here. What is the adjacent here?
The side on the bottom.
Good. Because it's right next to the angle we're looking at. And then this would make this the opposite side. Okay, so we're just identifying right now. Now we're going to draw 2 more triangles. Let's draw a triangle the same way on both sides. Okay, over the weekend, here's what I want you to do. Please finish up section 2-3's homework that I signed for you last night. What else do you have to do on Monday? Or Tuesday, sorry.
Problem sets.
Prop sets are due Tuesday.
Which I did.
Finish up section 2-3 over the weekend, please. You can maybe expect a possible 1-question quiz on Monday.
No, I just turned it. I didn't put it on turn today. It's not quiz